Today we're going to go over the quadratic formula. Perhaps one of the more useful formulas you'll ever come across, and certainly helpful for factoring quadratics. Sometimes you will get quadratics that are pretty painful to factor. Sometimes you'll get quadratics that have that aren't just simple things like x squared minus 4x plus 4, right? Where we just have a 1 in the x that we don't have to worry about. Sometimes you'll have super complicated quadratics, like say 32x squared minus 5x plus 10. And this poses a real headache for two reasons. And we're actually trying to factor them, right? We can't just say, oh, x plus a times x plus b, right? If we do that, we'll just get x times x or x squared as we're distributing. But we don't have x squared in our problem. We have 32x squared. So not only do we have to worry about what we multiply together to get, say, 10, or what we add together to get, say, negative 5, we have to worry about an additional term, the two additional terms that we have to multiply together to get 32 in this case. That's two additional terms. That's so much work. So, and especially, it's especially bad when we can't factor out, this frontal term, right? 32 doesn't go into 5, doesn't go into 10. We're really stuck with this 32. We cannot get rid of it, and that sucks. And that's where the quadratic formula comes in, and that's where it's so helpful. And it says, hey, if you have a quadratic, one of these pesky, 32s or 64s or any number hanging off the front of that x squared, here's what you can do. If you have a quadratic like a x squared, where a is a number, plus bx, where b is a number, and c, where c is a number, well then your solutions, right, your a's and your b's, right, if we were to factor this out and we would get, your a's and your b's, right, what you would do to get, those values are the solutions when you plug in the values of this, right? So let's pick an easy one to do. Let's say 5x squared minus 8x plus 2, right? Let's do that. So minus 8, that turns into a positive 8, plus or minus, that's 8 squared, or 64, minus 4 times 5 times 2, all over 2 times 5, or 10, and x equals this, right? So the values of this equation that are true, so that this value equals 0, the factors of this equation are contained in this formula. Right, so let's keep going. Right? So we have x plus or minus 64 minus 40, which I can actually just rewrite as 24 over 10. And I notice 24 is actually 6 times 4. And since we can multiply what's inside square roots, we actually have, that's the same as square root of 6 and the square root of 4. The square root of 4 is 2. So what I have is 2 times the square root of 6. So I'll rewrite that just for clarity. Now to simplify, I notice, hey, the numerator and the denominator both have 2's. So I'm going to pull out 2's from them, right? And if I were to go up and do that here, I'd be left with 4 plus or minus the square root of 6 over 5. And that plus or minus symbol might look a little unfamiliar, but don't worry. It basically means we have two solutions. We have one where it's 4 plus the square root of 6 over 5. One where we have 4 minus the square root of 6 over 5. Basically means, hey, for this thing you have two values, which makes sense because we know when we're factoring quadratics, we end up with something like x plus a times x plus b, right? Where we have two different values that get us the same thing. And now these are our a's and our b's. If we were to take these and plug this back to the original equation and then do the distribution, right, we would get that which resembles our original equation. If we were to take these values and plug them back into this original equation, we would get 0. And that is the magic of the quadratic formula. It allows you to deal with really, really complicated quadratics, find their solutions, factor them nice and easy. Thanks for watching. I hope you enjoy, and I hope you have a great day.